Okay, few more results. As n approaches to infinity, you know, 1 by n approaches to 0 because 1 by infinity is 0. Okay, similarly, as n approaches to 0, 1 by n approaches to infinity because 1 by 0 is infinity. With these two results, I can say the expression of the form, say as x tends to 0 minus, then 1 by x approaches to minus infinity because when it approaches to the negative values, it approaches to minus infinity. As x approaches to 0 minus, 1 by x approaches to minus infinity, so that e power, whenever we approaches an exponential value, e power 1 by x, that is e power minus infinity, approaches to 0. E power minus infinity means, uh, for that you should know the value of e power infinity. As x approaches to 0 plus, above 0 values, 1 by x approaches to plus infinity. So e power 1 by x is, e power 1 by x in this case is e power infinity. E power infinity is infinity because e power infinity is, as exponential power increases, e power 2, e square means the value of e is 2 point, lies in between 2 and 3, 2 point something. So their power, 2 square, 2 cube, 2 power 4, etc., 2 power 10, 2 power 100, as it approaches to infinity, the values also approaches to infinity. So it is e power minus infinity, reciprocal of that. Say e power minus infinity means 1 by e power infinity. So 1 by e power infinity is 1 by infinity, that is 0. So e power minus infinity is 0. E power plus infinity is infinity. Okay. With this you can also remember the one of the important results from your, uh, you might have discussed in limit of a sum in geometric progression, that is limit a power x. This idea will arise in sum to infinity of a GP. Limit of a power infinity as x approaches to, say, infinity, that is equal to 0 if a lies in between minus 1 and plus 1 particularly. Minus 1 and plus 1 particularly, because if it is lies in between minus 1 plus 1 means the value of a, say minus 0 point something or plus 0 point something, all are decimal 0 point values. Okay, those 0 point values towards higher power will be always equal to 0 only. Either it is in the negative region, say andre idu 0 na neighborhoods, below 0 up to minus 1, above 0 up to plus 1, 0 point something or minus 0 point something, all these value will approaches to 0 as x approaches to infinity. Whenever power is to the higher term, this value will approaches to 0. Okay, with this you can also remember few shortcuts related to these exponential terms. Okay, one is limit as n tends to infinity of a power n plus b power n whole power 1 by n, whole power 1 by n is equal to 0 if a is more than b is more than 0. Condition is a power n plus b power n whole power 1 by n is equal to, sorry, this is a, not 0, is a power n plus b power n whole power n is a if a is more than b is more than 0, both are positive values, whole power 1 by n as n tends to infinity. Similarly, limit as n tends to infinity, a power n plus b power n plus c power n whole power 1 by n is also equal to a if a is more than b is more than c is more than 0. So a is a bigger value among this. Therefore, limit as n tends to infinity of a power n plus b power n plus c power n whole power 1 by n is equal to a itself. You can remember these two important results. With this, I can also add one of the important result which related to limits at infinity. I can say in general these are all results which related to limits at infinity. The value is approaching to infinity, so it is limits at infinity. Now most familiar results of the ratios, limit as n tends to infinity. I can define here variable as x, so I'll take it as x. X tends to infinity. Function is a ratio a naught x power m plus a1 x power m minus 1 etc. is a polynomial function up to some constant, say am, divided by b0 x power m, say some other term you can take, say n, plus b1 x power n minus 1 etc. up to bn. Okay, ratios you can see a0 x power m plus a1 x power n minus 1 to am, b0 x power n to bn as extends to infinity. The outcome of this result, whenever limit approaches to infinity, x approaches to infinity, the outcomes of these results are, first one, this is equal to a0 by b0 if m is equal to n. It means if degree of the numerator is equal to degree of the denominator, then the result is a0 by b0. Got it? This is b x power n, don't get confused. Only coefficient of the highest degree, a0 by b0, if m is equal to n. Second case, 0 if m less than n. Okay, and plus infinity if m more than n and both a0 and b0 must be positive or both are negative. Say product of a0 and b0 should be more than 0. It happens in two cases. When both a0 and b0 are positive, then also product is positive. If a0 and b0 are negative, both are negative, then also product is positive. Okay, and is equal to minus infinity if, same case, m is more than n itself but product is negative. Product negative means either a0 positive or b0 positive. Both cannot be positive, both cannot be negative. Alternatively, either a0 positive, if a0 is positive, b0 negative. If a0 is negative, b0 is positive. In that case, the product of these two terms, a0 b0, will be negative. So for this, outcome will be minus infinity. This is a very important shortcut to solve many problems of the limits when they have given in the fraction forms. Very important shortcut result. So we can see a0 x power m to am and b0 x power n to bn as limit extends to infinity. Outcome will be this. Okay, so coefficients you can see a0 by b0 if m is equal to n, degree of numerator and denominator is same, 0 if m less than n, and infinity if m more than n. Both terms are positive, or both terms means your coefficient of that x power m and x power n. Product of a0 b0, both are positive or both are negative, then product become positive always. If product is negative, outcome is minus infinity. We will move on to some of the examples for this.